Hi everyone. We continue. Probably the last video lecture for topic six. Topic six, which is multiple reactions. I just want to recap a little bit on the previous video, which is on parallel reactions. So the last video lecture, I introduced to you on how to maximize selectivity on parallel reactions. So maksudnya to maximize selectivity tidak tertumpu on parallel reaction sahaja. Actually, itu video lecture tu sebagai contoh sahaja. So meaning that after that video, you can try to find any questions to maximize the selectivity, but based on series reactions. Okay, for this video, the purpose is to find the concentration term for each species in a reactor. So kita mengambil contoh series reactions pula. So after this video, you may need to find on how to find the concentration term using parallel reactions. Okay, so let's get started. So for example that we have these series reactions of A to produce B, and from B to further produce C. So from A to B, the rate constant is K1. From B to C, the rate constant is K2. And for example that we take the series reaction in batch reactor. So again, ini adalah contoh kalau kita ambil batch reactor. So you can try on how to lepas ni lah on how to find the concentration in other types of reactor. Okay, back to here. So kalau these series reactions berlaku dalam batch reactor, so the first thing that you have to know is the design equation, or other name for design equation is mole balance, if you still remember, for batch reactor. So just to recall, the design equation is, so let's say I put I over dt. So number of moles over volume bersamaan dCi, concentration, over dt. And usually that for batch reactor, V is always the same as initial volume, because we can regard volume as constant. So the next is you need to get the rate law for every species. Okay, so you need to get the rate law. So let's say we do on species A. So untuk yang ini, we have A producing B and B producing C. Sama je Maksudnya saya just bawakan this reaction yang ini saya bawakan ke bawah instead of dekat sini sebab nak bagi nampak jelas. So meaning that the rate law for this one, kita akan dapat K1 Ca. Katalah this is elementary reaction. For this negative R 2A, I may put it as 0 sebab kita tengah cari rate law for species A saja kan. So untuk the second one, the R2A is 0 because why? There is no species A over here. Betul tak? So meaning that the rate law for species A is only this one. So the next one is you need to combine the mole balance and rate law. Okay, you need to combine the first and second step. In which that, sorry, saya patah balik sikit. First that, you need to find the RA net. Meaning that the RA net is plus R2A, so it's only K1 CA. Okay. Okay. Tak ada wrong pula. So the next is you need to combine 1 and 2. Actually, the answer for this we can find on the next slide. Let's see. Okay, this is the slide where I show you the mole balance for batch reactor. So next slide. Okay. Alright. Okay, ni yang saya tunjuk tadi. So the net reaction, you will get this. Because the rate law for the first step is this one. So yang ini, this is the step where you combine. This is the third step where you combined mole balance or design equation. Mole balance, other name is design equation, and rate law. So mole balance tadi katalah DCI, tapi I kita nak cari for species A, so we change it to DCA over DT, which is it is sorry for what you call that, for a batch reactor is going to be RA, right? So your RA adalah you dapat, because just now you already identify RA net U equals to K1CA, right? So RA here so mean negative K1CA. Okay. So from here, bila you operasikan dia, in which that bila you buat you rearrange DCA over CA equals to negative K1 DT. So yang ni saya tak nak tunjuk, nanti you akan dapat jawapan macam ni. Okay. Just want to show you also that your R1A here, because R1A yang ni kan, A kepada B, which is this one is R1A. You akan dapat, tadi you dapat K1CA, which is the relative rates is because this one shows the disappearance of A, which is the relative is the same as the appearance of product B. Okay, next slide. So again, we still in the same series reactions of A produce B and C. So tadi kita dah buat dekat species A. Sekarang kita nak buat dekat species B pula. So again, you have to restart the step in which that the mole balance for species B, meaning that DCB over DT equals to RB. Okay. Second step is you need to find the rate law for species B. So ni saya pecahkan A kepada B and then B kepada C. At these two steps we have species B. So maksudnya you kena buat lah. So tadi kat sini you dapat R1A, tapi yang kita nak adalah B, R1B. So this is the same as K1CA. So in this case it is actually R2B equals to K2CB. So meaning that your RB net is going to be negative R1B plus negative R2B. So meaning that it's going to be the same as negative K1CA plus K2CB. Okay. Ataupun kalau nak kira dia punya RB net saja, you akan dapat you kena bermain dengan positif negatif dia. So maksudnya kat sini negatif. Okay, jadi sini K1CA okay, RB net. Okay, the third step is you need to combine the step 1 and step 2. So have a look at this next slide. Okay, nampak ni. Alright, so saya tunjuk balik. So you still ada this kind of series reactions. A kepada B kepada C. Sekarang kita nak cari mole balance untuk species B. So bila you dah buat tadi you dah buat rate law dia. You dah buat rate law dia R1B, R2B kan. Lepas tu you cari rate net for B. So you dapat ni tadi K1CA, K2CB. So kat sini adalah where you combine. This is the third step. In which the third step you combine mole balance and rate law. So tadi you ada dCB over dt equals to RB. So bermakna dCB over dt equals to K1CA minus K2CB. So yang ini kan. So bila you apa nak cakap, elaborate more, in which tadi CA you in previous step you dapat CA in previous slides kan, you dapat apa tahu CA not exponential something which is you dapat yang ni tadi. So ni you masukkan dalam ni, so you akan dapat beginilah kan. And then you rearrange and in which that this K2CB you pindahkan ke arah ni, so you akan dapat this this answer. And bila you integrate this type of term, you akan dapat this kind of answer. Okay. Try to stop here. Later there will be tutorials. I will upload the tutorials question and I try to show you some of the answer. Thank you.